this computer. Okay, hi everybody. Welcome to our November lightning talks. Much like last few lightning talks, there are some ground rules here that I'm going to go over. Today we have 4 lightning talks for you, 3 of a technical nature, and we actually kind of trying to start something new this time where I'm going to have one person deliver a lightning talk on something that's important to them, a hobby, a skill that's maybe outside of the software development landscape. So let's go over the ground rules real quick. So each presenter is going to roughly talk for about 5 minutes, maybe a little bit longer, a little bit shorter. We prefer people not ask questions or comments during the presentation to let them keep going, but we will have a thread in the Lightning Talk Google Chat space. So if you're not in the Google Chat space, that's called Lightning Talks, or Lightning Talk, I think is what it's called, Lightning Talks, sorry, plural, then send me a message in Google Chat and I'll add you to it. But what I'll do is I'll post a thread at the beginning of each person's talk. And if you have questions or comments or compliments during or after the talk, you can post it there and the author of the talk will address the comments and questions after their presentation concludes. And as you can tell, the meeting is being recorded. And today, our agenda, we have the versus graph by Jan, we have Lisp Macros by Ed, we have Metacontroller by Mike, and we have the hows and whys of sailing with Matt. So without further ado, Jan, you can start us off. I'm going to stop sharing my screen.
Sure, let me share my screen. Oops, that's not what I wanted to share. Let me see. Okay, there we go. The versus graph. Hey, everybody. I'm Jan. I'm going to talk about the versus graph, which is something that I have read a while back and I thought was cool. And I applied it multiple times over the course of the years. So I just wanted to give you an idea of what that is. It all is about leveraging Google's wisdom of the crowd to gain insights into things that you're interested in. So let's before I go further into that, what that means, let's take a quick look at Google here, at the Google search page. And if we type in here something, for example, the big L, right? You'll see Google is suggesting, how that might, continue. So the Big Lebowski, the Big Leap, the Big Lead, depending on what's currently, I guess, trending, you'll get different results here at the top, right? And the idea is to kind of leverage this this auto suggestion or this continuation suggestion here to create a graph, and we'll see how that looks like in a second. But the idea is to do something like this. So, for example, you say Accenture versus. So to get to map a landscape of what's it called, a product or I forgot the word for it. Like if we are interested, for example, in like Accenture and their competitors, or how the landscape of the contracting companies look like. So we can take a look here and say Accenture versus, we get a couple of suggestions here, Deloitte, Booz Allen, McKinsey, all these things. And then we can go ahead and do the same for the suggested terms here. So then we can start off with McKinsey. McKinsey. And we get maybe different suggestions here. So Goldman, and then we can go further and say Goldman. What's coming up with Goldman? Goldman Sachs versus JP Morgan, and so on and so forth, right? So the further we drill into this, the more kind of terms we get that are related to our initial term, and we can then kind of paint a picture of that. And the way that it looks then, if we do that, so first of all, this is kind of the initial kind of query that gives you the suggestion. So if we run this here, versus 1, you see here, this is the endpoint here that we give like the big L here, for example, as an initial, as a seed. And if we run this here, you'll see the same that we saw in the Google UI here. It'll give us the suggestion: Big Lebowski, Cast, Big Leap, Big Lead, all the same things that Google gave us here. Big L, right? Some things. And again, now this then gets a little bit augmented into this here. Same endpoint here, but we start off with a term like Accenture, for example, and we will search Accenture versus, get all the suggestions back, and do the same thing with the suggestions again. So feed the suggestions back into the same API here, and ultimately plot a graph from that. And how that looks, I'll show you right now. Let's see. So for example, we say here, what is it, Accenture. So this goes out, finds Accenture versus, collects all the suggestions, goes back into the with the suggestions, does the same thing with the suggestions, and paints this graph of relations basically. So we see Accenture, McKinsey, AFS, Deloitte, Booz Allen, all those different things. And it kind of gives you like an idea about about what you're interested in. Like for example, we can do the same with SpaceX, for example. Let's do SpaceX. Can you, and by the way, can you see this graph actually? Is it legible?
Yeah. Okay. Yeah. Do you mind just zooming, making the font bigger if you can?
Zoom in a little bit. Right. So it's the same with SpaceX as a seed. And SpaceX, oops, sorry. We see Blue Origin, Boeing, Tesla down here. And, not everything kind of is really relevant in this context. So, like NASA salary, for example, is, something that you can like later filter out if you want to create like a nice graph for some presentation or something like that. Or, sometimes you end up like with synonyms. I don't see any right now here. But here, this small space X here, this is like a programming error, I guess. Should have started with the space X and all lowercase letters. Anyways, so I have a couple more examples here, just to give you an idea. Again, you can get very sophisticated with that in terms of filtering and finding synonyms for things so that the graph later kind of aligns nicely. But ultimately, this is basically what it is. So this is your Volkswagen. You have like the German car manufacturers down here. You have down up here, you have like more the Asian car manufacturers, and and so on and so forth. It also works with like movies, Pulp Fiction. So Pulp Fiction. Let's see if it can, so those are kind of like suggestions but then go further into other suggestions. And that's pretty much it. That's all I have. Actually, you know, the last time I talked about Apache Airflow, and I just want to bring that up too here because I have it noted down. I think I had this graph in my presentation, I'm not sure. That kind of tells you a little bit the landscape of, I guess, process engines, or whatever you want to call that. You have all these different products here. If you haven't heard about them, then it might be interesting to take a look if you are considering to do something related to that. Anyways, this is the idea. This is all I have. Thank you.
Thanks, John. That was excellent. That's really cool. I enjoyed seeing that. Definitely have a couple of questions in the thread when you get a chance. Up next is Ed.
All right. Hi, my name is Ed McDonald. I'm going to try to keep this in 5 minutes, but I don't know if I'm going to be able to do it, so I'm going to move a little bit fast. I'm giving a presentation on Lisp macros entitled, What Can Lisp Do That Blub Cannot? If you want to know what blub is, in the video, just copy the link. It's Paul Graham coined the term. It's an interesting read. But first, we're going to talk about Java and how does Lombok work. And so now I'm going to go to some code samples here. And before we even talk about Lombok, we're going to talk about Java beans and what I'm going to call Lisp beans, for lack of a better word. So on the right-hand side here, we have what any Java programmer will recognize as the standard Java bean pattern, where you declare some fields, then you declare a whole bunch of getters and setters, basically 3 lines of actual code, and then how many ever extra lines of boilerplate. You'll notice though, the Lisp code looks shorter, but it has the same amount of boilerplate. You have to declare the 3 fields, which are all that matters, but then you also have to tell it what the getter and setter's names are. That's what the accessor is. And you have to tell it what the init arg name is, because Lisp uses named values in its constructors. So lest you think Lisp is more concise, this is proof that it's just as bad as Java in some cases. So I want to show quickly how to use both of these classes. Here, Java actually wins. It's 1 line shorter, but a lot of this is boilerplate. This is not boilerplate I'm going to fix though, but the important part here is in Java, you declare a new person and then we print it out. In Lisp here, you declare a new person and then you print it out. The code is almost the same. This is just proving that I can use these classes to do meaningful stuff. So on the left-hand side, you see that I create a person, Lisp prints it out, first, middle, last name. On the right-hand side, I create a person, Java prints it out, first, middle, last name. So how can we make this better? Now we finally get into Lombok on the right-hand side. Lombok is a Java library for removing boilerplate. So here we write the code that we actually want to write. We create a class and we list the 3 fields that are in that class, and that's it. We just add a data annotation and an all-args constructor. The all-args constructor does exactly what you expect. It generates a Java constructor for you that accepts all arguments. The data annotation generates all the rest of the boilerplate in the previous example, plus a few more things that you can read up on. It implements equals and hash code, but those aren't pertinent to this presentation. On the left-hand side, you see that I've done the same thing in Lisp with this magic thing called data class. Now, the magic of Lisp is that I get to define data class, whereas in the right-hand side, I don't define what data and all our constructors do. But anyway, so we're going to come back to that. That's the meat of this presentation. But now I just want to prove to you that both of these things still work exactly the same way. On the Java side, you'll see all I've changed is that I'm now using a different person class, but it behaves exactly the same. So from the client's point of view, nothing has changed here. This code is exactly the same, except now I say from Lombok to Java. And the same is true of the Lisp side. The only thing that has changed here is I'm changing the name of the class because I created a different class to capture that. And they still work exactly as expected. Okay, so now we're going to talk a little bit about how Lombok works. So that was a lot of magic. How does it work? Well, Lombok hooks into the Java compilation process as an annotation processor. And there's a link at the bottom that describes where I found this. Highly recommend reading it. It's just the Google Groups discussion. It's very interesting. But this is the summary. Then when Lombok hooks into the compilation process as an annotation processor, what that does is it tells the compiler to give it an opportunity to do something when one of these applications, or I'm sorry, annotations are encountered. And the question is, what does it do? This was mind-blowing to me. What Lombok actually does as an annotation processor is the Java compiler uses the hook and says, Lombok, I've encountered an annotation. Then Lombok modifies the abstract syntax tree that the compiler is currently in the process of generating right in memory, so that when the compiler comes back around to, say, generate some bytecodes from the abstract syntax tree, it's doing so from an abstract syntax tree that has been modified without its knowledge by Lombok. So the whole point of this is that is fantastic. That's amazing magic. That is not something that I would expect any Java developer to know how to do. So how does Lisp work? Well, let's take a look at this over here. Actually, sorry. We'll continue here and I'll show the example later. Well, in Lisp, you can define macros, and macros are functions, but a very special type of function. They accept Lisp expressions as input and output, and they hook the same way that Lombok hooks into the compilation process. They hook into the Lisp evaluation process. So when Lisp is evaluating your program, your expression, when a macro is encountered, it uses that macro to transform one expression into another. So the expression it transforms is essentially a DSL that you've chosen to write. It can be whatever you want. You just have to specify how it transforms into some Lisp expression that is common Lisp standard that the Lisp evaluator knows how to evaluate. So let's see that in action. This is, when I said that I was going to get back to what data class actually was, this is what it is. It's a macro. So I'm defining a macro called data class. And I'm saying this macro takes a name, which we showed in the previous example, and then a list of properties. So the name was person data. The properties were first name, last name, and middle name. The magic here is that all of this code that I'm writing is still Lisp code. Like I would expect a Lisp programmer to be able to write macros that in fact define DSLs and transform the language. And I have the full power of the Lisp language to do so. Map, car, Lambo, those are all common Lisp functions. Now what's really interesting, so I've defined this macro. What I want to do, this is a lot of boilerplate. All that matters is this code right here. I'm saying, this is exactly how I used the macro in the previous example. Its name is data class. I said, this is the name of the class I want to create, and I want these three fields. Now I'm just asking Lisp, instead of evaluating this, just show me what it would be transformed into. That's what macro expand does. And you can see, without understanding a ton about macros, Lisp has this tendency to capitalize everything because it is not case sensitive. But if you were to uncapitalize this and indent everything the way I had done in the first example, you would see that this is exactly the boilerplate in the first example that I've reproduced without having to do any of the machinations that Lombok had to do. Okay, and I'll end with a quote from Peter Norvig. This was on a blog post he wrote called Teach Yourself Programming in 10 Years. You can read the whole quote in the video, but I'm pointing out the one line that I've highlighted. Learn at least half a dozen programming languages, ... including one that supports syntactic abstraction like Lisp. And I would argue, I don't know of any other languages that support syntactic abstraction. So if you want to mess around with syntactic abstraction, which Peter Norvig says you should, you only have one choice. You have to learn Lisp. That's it for me. Thanks for watching. Questions in the channel.
Thanks, Ed. Awesome. And for those of you that were curious like I, Lombok is an island in West Nusa Tenggara province of Indonesia. So that's presumably where they got the name from, though the connection, I'm not sure. That'll leave that up to you guys to figure out. Okay, next up, we have Mike Smith.
Okay, sounds good. Let me share my screen.
Yes, we can see it, Mike. Okay,
cool. So today I'm going to talk about Metacontroller. So in Kubernetes, you have this like concept of an operator or controller where you basically declare what you want. So if you want to have a pod, a config map, a service, other things like that, you declare it, and then a controller is reconciling, creating those objects for you, so you don't have to worry about how it's done. You just tell it you want it done. So typically, those are all done in Golang. That's the language of Kubernetes, pretty much. There's other exceptions, of course, but Metacontroller is a project that was originally created by Google, and now it's a community-driven project, and it basically abstracts all those pieces and allows you to create a controller with basically JSON. So you'll have a webhook and you'll get current state of the cluster, and you can give a desired state. It's, as I said, it's open source here. You can see some details here. And now let me show you what this actually looks like. So, oops, wrong one. Cancel it. Okay. So in Metacontroller, they have a concept of a composite controller, which is like a parent and child. And then there's a decorator controller where you basically have an object and you can decorate it with other things. So in this example, I'm going to show is basically in Kubernetes, you create a deployment, and then you can decorate it with a pod disruption budget and a service automatically through with a controller. So in Metacontroller, you basically define your object. So here, my parent is going to be a deployment. So anytime I create a deployment with this label here, it will it'll observe for pod disruption budgets and services. And anytime it sees any change in this deployment or children, it will call into this webhook. And in this example, I just did some basic JavaScript. So it's actually just I just copied some code. It's just a JavaScript boilerplate. And then the logic here is in the sync hook. Basically, if you get a request in, you can see certain things, and then you can return your desired result. So here, literally all I'm doing is saying, hey, I want a pod disrupt PDB with the same name and some label selectors. So let me show you what that actually looks like. So in the cluster here, I actually have, so Metacontroller is running. So it'll observe any of these objects. For example, this is the one I just showed you where I've already created this. So this is saying, look for deployments and then hit this endpoint. So over here. And then this is the actual controller that was implemented by me. So this is just the returning the JSON of the desired results. So if I go ahead and I have an example deployment here. So there's a lot going on here, but on the right-hand side up here is all I did was create this deployment, and I gave it a label right here with this simple deployment. And since this is found, Metacontroller will basically discover it and then start to perform its operations on it. So here you can see the pods that's just normal Kubernetes, but then here a service was automatically created, a PDB was created. And if I come over here and I delete this, for example, it comes right back because it's defined currently in this webhook response. So basically what's happening is Metacontroller observes state, sends a webhook to this deployment, it responds with what it wants, and then Metacontroller is basically the interface between Kubernetes. So this is in JavaScript. There's a lot of examples in Python. I've done stuff in Scala. So it's basically just a language agnostic way to develop Kubernetes operators and controllers. So yeah, that's what I wanted to talk about today, and that's all I have.
Great, thank you, Mike. Appreciate that talk. All right, and last up, we have Captain Matt. He'll take us home, Matt.
All right, thanks. Let me share my screen. All right, sailing. Excuse me, sailing, how and why? A lot of people have seen sailing, and they ask me questions. How do you sail? Like, is it really difficult to sail? It's really not very difficult. There's some very fundamental principles you apply. I taught myself how to sail using YouTube. These are some of the sailboats I've owned in the past. I currently have the red one. So I'll give you a little bit of info as to how sailing works. The main thing sailing requires on is wind, obviously, and the different points of sail determine how fast you're going to go, which direction you're going to go, or what have you. On the left side of the screen, this is called a wind vane or a wind gauge or wind meter. And it's very common to see on sailboats. It's obviously pointing towards the direction of the wind because that's what we care about so much. And these two black things, they're called the hammers. And anytime this tail of this airplane-looking structure is in between these two black hammers, then you're not going to be going anywhere, because that means you're in the hammers, you're sailing too close to the wind, and the sailboat just won't move. If you look on the right side of the screen, we've got the no-go zone, and that's kind of what we're talking about there. It varies in degree based on the type of boat you're sailing on, but it's usually around 40 degrees to 0 degrees. So, and obviously 320 to 360 degrees. If you're going into the wind, you're not going to go anywhere. If you come off the wind a little bit, let's say close hauled here, you can see the wind is hitting us on the left side of the boat, which is the port side of the boat. And you can see how the sails are aligned. They're very tight down the middle of the boat. And when you're sailing upwind like this, because you can see the wind directions coming from the top of the screen here, when you're sailing upwind, the sails actually act like a airplane wing, and you're actually getting lift from the sails. And the lift that you're feeling from the sails, it is what generates the boat propulsion. So it acts very similar to an airplane wing in that respect. Obviously, when you get further away from the wind, you're going to have different experiences. So on a close reach like this, you're not quite tight on the wind like this. So you have to release the sails a little bit. And you can tell in these pictures, the sails are in about the same position. They're different position on the boat, but positioned to the wind, they're at about the same angle. And that's how we're going to get that same amount of lift. You can go very fast on this close hauled like this. Different boats are designed different ways. You've seen sailboats have keels on them. That keel there serves a couple of purposes. One of them is it prevents your boat from heeling over so much, which is tilting over so much. So the bigger the keel, in theory, the less the wind is going to knock you over. And instead, you can take that wind and turn that into lift by having, the more upright your boat is, the faster you're going to sail, basically. So it's going to prevent you from heeling over like that. So that way you can go as fast as you want, as fast as you can, rather. When you get down to a beam reach here, then the wind is hitting you right on the side of the boat. And for most boats, this is the fastest point of sail because the wind is hitting you directly at a 45-degree angle. It's super easy to set your sails, and it's making your boat go as fast as possible. Then you start getting into downwind points of sail, such as a broad reach and running. And that's where the wind is literally just pushing you along. The sail is acting very differently from when you're close hauled and an airplane wing style. Rather, this way, it's just pushing you. Obviously, if the wind is 10 knots, which is 12 miles per hour, then you are not going to be, it's going to act very differently here, because 10 knots close hauled, you'll most likely be going faster than 10 knots running downwind, because you have what's known as apparent wind, which is the wind that you feel. If you think about it, if you're walking along at 5 miles an hour and you've got 5 miles an hour of wind behind you, you're not going to feel any wind at all. So you need more wind to get you going, but it's a much smoother ride. And this works on either the port or starboard tack. And upwind sailing is often used in most racing, sailboat racing. So I race my sailboat, and these are pictures of us racing, and you can see how the boat is heeled over like this. In the picture on the right, you can see how the boat is heeled over quite a bit. It's a fairly small boat, and you can see his sails, like I mentioned, they're really tight in. They're right running down the middle of the boat, right? So that way you can they can turn it into an airplane wing and get that lift, which pulls you up and makes you go faster. The reason why we have people sitting on the rail here is what we call them rail meet, is because we're trying to offset the balance, the heeling of the boat. We want that boat to stay upright as much as possible so we can turn that wind into propulsion rather than having it heeling us over. Different story when you're going downwind. You've got, these are called spinnakers. And so when you're downwind, you're just getting pushed by the wind. So you really want as much sail up as you can. You've probably seen these big, pretty boats out there. And this one on the right, you can see they don't even have their main sail up. They just have a big spinnaker up there. They're catching as much wind as possible. Because if you pictured another sail up here, it would just be blocking the spinnaker. So you can just run like this. And you can go really fast and really smooth with these are big sails, but they're super lightweight. So that's the how on sailing. Why do we go sailing? Is because it's a great time to spend with friends. You can have a beer. You can watch some beautiful sunsets on the right. It's just a fantastic way to spend your free time. If you're interested more about sailing, there's a ton of video blogs out there of people who do this, who just sail around the world for a living, really, because they get paid via people who watch their videos. One of the big ones is called Sailing the Vagabond. If you have any interest in what I've mentioned here, it's totally interesting. I've put a link here, and I'll put it in the Lightning chat as to watch one of their videos, which I think is really informative about sailing and just living on a boat in general. That's it. Thanks, guys.
Thank you, Matt. Appreciate it. That was very interesting. So this concludes our lightning talks for today. I believe we are probably done for the year, but if there's interest, please do reach out to me. We'll start collecting people who are interested in giving lightning talks I have a document out there that you guys have seen a link to in our Google Drive. As you can see, it's usually pretty quick, pretty simple to put one of these things together, and can be fun, and it's definitely entertaining and informational for everyone, and educational for everybody that's watching. So thank you to our presenters. Thank you to Jan and Ed and Mike and Matt today. And hope everybody has a great rest of your Thursday. Bye-bye.
Thanks, guys.
Thank you.
Thanks. Bye.